see, they are closed geometries. So you can find out where the energy is actually going out or reaching out to, right? For a closed, enclosed, structure like this, right? Like I said, whatever is going out of it must be falling on one of these places. But when it is open-ended, right? How do you actually find? It is subjective. Suppose there are two discs like this, of same diameter or different diameter. So how would you find actually what is F12 and F22? You cannot use these relationships like this. You can't say how much is falling on the other surface and how much is escaping. So that requires, right, a different approach. You can develop mathematical relation for that in terms of the sizes of, like we discussed earlier already. So the shape factor depends on the size, shape, form of each of these plates and also the positioning of one with respect to the other. So that means the angles, the dimensions, like the diameter which reflects the size of this, as well as the distance between them. So the mathematical relations are available, and the same thing, right, for our convenience are put in the form of graphs and tables. So suppose if you take this case, two parallel concentric discs, right? You see an x-axis L by R1 and this is R2 by L. Okay, so this is L by R1 on x-axis and the curves are R2 by L. So if you know R1, R2 and L, you can find, right, the value of shape factor. Okay, so now another graph that is available. This is applicable only for the discs that are of same size. Diameter of this and this is same. And see here, if you know the distance x between the two discs and diameter of the disc, both discs have same diameter. So d by x you find and then you project it onto the y-axis, so you will get the shape factor. Right? So the shape could be anything. Now this is another shape where these are perpendicular rectangles, surface 1 and surface 2. Now the energy that is leaving surface 2, some part of it will fall on this and remaining will escape, right? So therefore, how do you find it? All the dimensions are taken, right? X, Y, Z, which will reflect the sizes of these plates. And here, depending on the ratio of Z by X and ratio of Y by X, you can find a point and then project it onto the y-axis, which is the shape factor between the two given surfaces, right? So this is again the case of cylinder in cylinder, two concentric cylinders, right? So here see, there are different possibilities. See, this is inner cylinder and this is outer cylinder, and the radiation exchanging surfaces are outside surface of the inner cylinder and inside surface of the outer cylinder. See now, suppose if you take surface 1, the energy leaving it can fall on 2, and also you see this top portion, this portion, as well as suppose if this is cylinder of certain length L, so this not only falls on the curved surface of the cylinder 2, but it also falls on the flat surface or the annular space between these two cylinders. Are you getting me? So that is also possible on either side. So therefore, if you assume this as one surface, similarly on the other side, say, both ends, let us say. So this is lateral surface, this is front surface, and this is back surface. So let us imagine the cylinder is standing in vertical position like this, right? So now this is the inner surface of the outer surface of the inner cylinder. Now this, imagine a concentric cylinder is inserted onto this. Now the rays leaving this can fall on the inner surface of the outer cylinder and also they can cover the area on the both ends, this end as well as this end. So all those parameters need to be considered in order to find the shape factor, right? So now I am giving you this task. At least each one of you take any two different shapes that we have not discussed so far. Any two of your choice. Refer any textbook and then get those 2 or 3 problems solved for the next class. Right? Please make a note.